Great, so this is the last one of the day, so let's make it quick. We're going to talk about account abstraction and Paymasters and how both improve user experience and disrupt transaction fees. So about myself, my name is Antonio, as I told you, and I'm a developer relations engineer at Matter Labs. Basically, my job is to educate developers on the different features of zkSync and also to help projects migrate the projects to zkSync or just deploy them on zkSync. I also have a blog that is Solidity Tips, and if you are starting learning Solidity, you can go there and learn a few things. And apart from that, that's my Twitter profile at Ufano with a 4, in case you want to follow me. So this is the agenda for the next half an hour. It's not going to be super long. We're going to talk about what is zkSync era, just a quick overview. Then we're going to talk about the different types of account on Ethereum and the UX problems that we have right now in Web3. We will talk about account abstraction in general and about EAP 4337. And finally, we're going to talk about zkSync era and how we have implemented account abstraction on it. And finally, we will talk about Paymasters and how to create them and how to implement them in your application. So, at Matter Labs, our mission is to accelerate the mass adoption of public blockchains, and we are doing it during the last few years by building zkSync. As you guys know, Ethereum is the most popular blockchain, so our job with zkSync has been to scale it and to make it more usable for people. So, zkSync era is a layer 2 rollup powered by a zk EVM. In short, it increased the Ethereum scalability by moving the execution of the transactions of the layer 1 onto the layer 2. It also reduces transaction fees by bundling transactions together into batches, so the fees for those transactions is split between all the transactions of the batch. And finally, it inherits the security from the L1 because we are using validity proofs to send that are sent to the layer 1 where it's validated before we update the state. One of the coolest things about zkSync era is that it's EVM compatible, so you can use a smart contract written with Solidity and Viper. So again, if you have an existing application that is running on Ethereum or in other EVM, you just have to take your smart contracts and you can bring them to zkSync. You don't need to rewrite your whole application. On top of that, if your contract have been audited, you don't need to re-audit your code, which is super, super expensive. And we can also say that it's an EVM plus because we are not limited to the EVM features. We also have account abstraction and Paymasters already live on zkSync, which are pretty cool because they improve the user experience a lot. To understand how account abstraction and Paymasters improve the user experience, we first need to know the problems with the user experience right now. And before knowing these problems, we need to see the types of accounts that exist on Ethereum to understand how they are causing these problems, let's say. So, on Ethereum right now, there are two types of accounts. We have externally owned accounts and we have smart contract accounts. The externally owned accounts are your typical MetaMask or Ledger or Trust Wallet. And these accounts, they have an address, a nonce, and a balance. And every single account is associated with a signer, and this signer has a private key and a public key. And these are the wallet that everyone uses. You sign your transactions with your private key, and they go into the network. On the other hand, we have smart contract accounts. They have an address, a nonce, a balance, but they also have the code of the smart contract itself. And these accounts, they are not associated with any signer, and very, very important, they cannot initiate transactions. What this means is that you can transfer ETH from your MetaMask to a smart contract account, or just to a smart contract. But if you want to withdraw that ETH from the smart contract, you cannot do it actively from the smart contract account. You need to have like a withdrawal method, let's say. So that's very, very important. So this is causing some issues right now. The bigger one is that this relationship between the signer and the account means that basically if you lose your private key, you lose your account. And if for whatever reason you find a private key, you will own the account that's related to. So this relationship, signer and the account, basically means that they are the same thing. On the other hand, private keys are a pain to manage in general, because even experienced users, they lose them, and normal people or people that are not in crypto, they are not used to remembering a private key or a seed phrase. A lot of people, they just keep their passwords written down in a POSIT in their desk, so it's not the best user experience. It's difficult for users. In addition, as we mentioned earlier, if you lose your private key, you are done, and there is no recovery. So basically, you lose your private key, there's no way you're going to recover it. And how many people have to reset their passwords, like from Google or any website? I mean, you do that almost every day. So that doesn't exist in Web3 right now. And finally, you cannot change the signature type, so what you use to sign your transactions. The logic to sign the transactions is hard-coded in the EVM, and yeah, there is no way to change it, and that's another problem. So that's all these problems are the things that account abstraction is trying to solve. And account abstraction is like a weird word or a weird expression that everyone uses lately. So let's try to understand what it is. And in simple terms, what we are doing is, instead of having this account related with this signer, we're breaking this relationship. So the accounts will not be related to any signer. And instead of having signers whose logic is hard-coded in the EVM, we'll put this logic into a smart contract. So a smart contract is fully programmable, so we can put any logic that we want. So you can say that account abstraction means using smart contract accounts. So these are the main differences of these problems and what they are for externally owned accounts and smart contract accounts. So externally owned accounts, they have this relationship between the signer and the account. Smart contract accounts, they don't have a signer, they don't have this relationship. With externally owned accounts, the logic to sign the transactions is hard-coded in the EVM. With smart contract accounts, that logic is programmable in the smart contract itself, so you can put whatever you want. Regarding the private keys, with externally owned accounts, they are difficult to manage in general, and with the smart contract accounts, you can use different types of keys to sign your transactions. You can use biometrics, for example, or you can use Google Authenticator, things like that. So you don't need to remember your 12-word seed phrase. And externally owned accounts, as we said, they have no recovery at all. If you lose your private key, you're gone. And with the smart contract accounts, you can program recovery methods in the smart contract. You can have social recovery, or you can have backup keys, or you can have backup people that can give you a transaction, give you ownership of the account back. So we're solving all these problems by putting a lot of the logic in the smart contract. Here are some features and UX improvements in general. We can use different signature schemes. By default, Ethereum uses ECBSA, so you can use any other signature scheme. Your smart contract account can be a native multi-sig account that needs to receive multiple signatures to approve transactions. You can create accounts that have spending limits, like, okay, I only want my account to be able to spend 1 ETH per month, something like that. Or you can have application-specific accounts. Imagine that you want your application to only be able to interact with Uniswap. And if it receives a transaction for another DeFi protocol or for OpenSea or whatever, the transactions will fail. That's some logic that you can put in the smart contract. You can also put recovery methods, as we said, and basically these are smart contracts. So they are fully programmable. Anything you can think of, you can put it in the smart contract. But there is a catch with all of this. As we mentioned earlier, only externally owned accounts can initiate transactions. So if we all say, okay, smart contract accounts, they are great, let's use them, how are we going to initiate transactions? There is smart contract accounts, they cannot do it. That's what EIP 4337 is trying to solve. This EIP is called account abstraction using an alternative mempool. So let's deep dive into it. EIP 4337 is like a big EIP. It introduces a lot of new concepts. So I'm just going to explain them super fast. So we have this concept of user operations. And user operations, to keep things simple, are transactions that belong or that have been initiated from smart contract accounts. So instead of being like normal transactions, we have this thing called user operations. Then the smart contract accounts will send these user operations to a dedicated mempool. So we will have externally owned accounts sending transactions to the mempool that we all know, and then we have smart contract accounts sending user operations to a dedicated mempool. So if we have a dedicated mempool, we need something listening to this new mempool. That's when bundlers come into place. Bundlers are nodes. It's still not clear if this will be like the same nodes from Ethereum or a specific client. And they are listening to this mempool, and they bundle a lot of user operations together, and they are sending them to a system smart contract. We can call it like a system smart contract that is called the entry point. Then this entry point contract is the one responsible of verifying that the transaction is okay and executing the transactions. So there's a lot of data here. So to make things simple, here's a diagram. So on top, we have the externally owned accounts. They're using the mempool that we all know, and then we have the nodes and validators. They're picking those transactions and putting them into blocks into the blockchain. The proposal is having smart contract accounts sending user operations to that mempool. This is a new mempool. And then we will have the bundlers taking these transactions, bundling them together, and sending batches of user operations to the entry point smart contract. And the entry point smart contract will verify these transactions, execute them, and put blocks into the blockchain. So, Paymasters. Paymasters are an extension that it was also introduced in EIP 4337, and they are like a middleman that can be used to sponsor transaction fees from other users, or basically to allow users to pay transactions in ERC20 tokens. And this is super, super cool. This is a feature that I really, really like. And Paymasters are just smart contracts. So again, they are also fully programmable, and they are an extension of the entry point contract. And we will see where they are in the transaction diagram in a minute. But basically, what they do is they allow users to have gasless transactions, or to allow users to pay transaction fees with ERC20 tokens, which is cool. So some of the use cases and features that you can build, again, pay fees with any token. If you are allowing users to pay fees with ERC20 tokens, you are basically increasing the utility of the ERC20 token itself. Imagine that Uniswap decides that in order to do swaps on Uniswap, you have to pay the transaction fees with the Uni token. The Uni token, instead of being used just for governance, it will have this utility. So utility brings value, so that's a good use case. You can have a paymaster that will pay the transaction fees of the users that have a specific NFT. This is pretty cool for DAOs, for example. You can have a paymaster that pays the first transactions of every month for each user. for example. And again, Paymasters, they are just smart contracts, so you can put any logic that you want in them. And this is how it will look like. Again, we have the two flows, and then in the entry point contract, basically, the transactions will have additional data saying, okay, I want this transaction to be processed by this Paymaster. So the entry point will send the transaction to the Paymaster. The Paymaster will run some validations to see if it will pay the fees or not, send it back to the entry point, and the entry point will create a block or add the transaction to a block. So this is basically EIP 4337 in 6 minutes. Super, super fast. It's a new transaction flow for smart contract accounts. But there is a catch. If you see here, Paymasters are on this end of the flow. So if you have an externally owned account, you cannot use Paymasters, which, okay, we have a lot of good things in EIP 437, but this is the catch. So this is the only thing that they can do. So when is account abstraction available on Ethereum? Well, EIP 4337 is still a proposal, and we don't know when it will be implemented, but account abstraction is already implemented on zkSync era, and the proposal from EIP 4337 was done this way to avoid doing changes at a protocol level on Ethereum. But we, at Matter Labs, we have built zkSync as a new protocol. We have built it from scratch, so we have made things a little bit different. So how is the account abstraction implementation on zkSync? Well, first, as I mentioned, it's integrated at a protocol level, so we had zero compromises, and the way we did it, I think it's a simplified solution for both users and for developers. How is it simpler? Well, account abstraction and Paymasters, they are first-class citizens. So that means that under the hood, all accounts behave as smart contract accounts. If you are using an externally owned account, under the hood, zkSync era is using a default smart contract for your account. So all accounts behave like smart contract accounts. More importantly, all accounts support Paymasters. You can use MetaMask with zkSync, and you can use Paymasters. And so this is huge. As all accounts behave as smart contracts accounts, we just need a single mempool and a single transaction flow. And all transactions for all types of accounts, they all go to the same mempool, no matter if they were initiated by an externally owned account or a smart contract account. And finally, inspired by EIP 4337, as all accounts behave as smart contract accounts, we have our own version of the bundler and the entry point contract. We call them our operator, and the entry point contract, we call them the bootloader. So how does this look? Here it is. So we have both externally owned account and smart contract account pushing transactions to a unified mempool. And then we have our operator picking those transactions, bundling them together, sending them to the bootloader. And then the bootloader will detect if the transaction has to be processed by a Paymaster or not. The Paymaster will do its thing, send it back, and then the entry point will execute the transaction and add it to a block. So as you can see, both externally owned accounts and smart contract accounts, they both can use Paymasters. So, okay, that Paymasters, they look cool. How do you actually build them? Before jumping specifically into how to develop Paymasters, just a quick reminder again that the developer experience on zkSync, you can write smart contracts with Solidity or Viper. So again, you don't need to rewrite the code of your applications. It's just Solidity or Viper. Developers can use existing tooling as well. You can use Hardhat, you can use MetaMask. Everything works out of the box. The Web3 API from our client is compatible with Ethereum as well, so you can do eth get block or eth get transaction receipt. same method, everything works the same. If you have a project, migrate it is just minimal changes. And we have SDKs in JavaScript, Python, Go, Java, and Swift. And these SDKs, they are built on top of the most popular libraries. So for example, our JavaScript SDK was built on top of Ethers. And we are just adding specific functionality for zkSync. But if you want to create a contract instance with the JavaScript SDK, you will use the contract address, the ABI, an assigner or a provider. So everything is pretty similar. The Python SDK is built on top of web3.py as well. So for developers, everything is super easy. As I mentioned, a Paymaster is just a smart contract. So you can put any logic that you want. Obviously, there are some rules that you have to follow. For Paymasters, they have to implement the iPaymaster interface. That interface is provided by us in the zkSync contracts package, NPM package. And there are two methods in this interface. The first one is validate and pay for Paymaster transaction. And the second one is post-transaction, which is optional. You can implement it or not. And this is like a very basic example. The validate and pay for Paymaster transaction that receives all the data of the transaction, and then you can run your validations. As I mentioned, you can check if the message sender has a specific NFT, or basically any logic that you want. Once you have checked that the validation is correct, you will check how much the transaction fees will cost in ETH, using the gas limit and max fee per gas. And finally, you will transfer that amount from the Paymaster contract, from the Paymaster smart contract to the bootloader. Because at the end, someone is paying for the transaction fees, so that's the Paymaster is the one that is paying. It has to send that amount to the bootloader. And finally, you just have to return validation success or validation or an empty array. Apart from that, there are two built-in flows for Paymasters, and this is useful from a front-end integration. One is the general flow, and the other one is the approval base. Basically, the general flow is anything. If you want your Paymaster to be protected by a password, you will use the general flow, and when you use it, you will have to send this password, or the user will have to send the password as part of the general flow. The approval base is specifically built for ERC20 tokens. So if what you want to do in your Paymaster is to allow users to pay fees with an ERC20, you will have to use this approval base flow. And what it will do is it will run the approved spending from ERC20. It will run it behind the scenes for you. So the user won't have to first approve, and then you will be able to spend the tokens for it. The built-in flow will do it for you. So for the user, it will be a single transaction. So okay, you have your smart contract. Obviously, you have to deploy it and you have to fund it. As we said, the Paymaster is the one that is paying, so you have to fund it with some ETH. From a front-end point of view, what you need to do is you have to encode the Paymaster parameters that your users will use. And for that, you need to use the getPaymaster params method from our JavaScript library, which is called zkSync Web3. And in this method, you need to pass the address of the Paymaster and an object with the type of flow. It could be general or approval based, as I said. And then the inner input will be just any payload that you need to run your validations. So it could be a password, a session, whatever, a session key, anything you want. And then you will send these Paymaster parameters as transaction overrides. So down there you have, imagine that you have a contract and you want to run a method of that contract, you pass the parameters, and then as transaction overrides, you will pass the custom data object, and in that custom data object, you will pass the Paymaster parameters and gas per prop data, which is an internal variable that we use for gas fees. And that's basically all you need to do, is write a smart contract and implements one method. From a front-end point of view, just encode some parameters and include them in your transaction. That's all you have to do. So, if you are coming to Denver, you are going to experience Paymasters yourselves, because we have built the food truck experience on zkSync using Paymasters. So let me show you how will that work. We have partnered with my Ether wallet, so you can use, I'm sure you have seen that they have booths all over there, and they're asking you to install it to get some tokens. So you can use a new wallet or an existing wallet. Here are just 2 screenshots. And on March 2nd, there will be this pop-up that says get free food, climb your Bitterbucks. Bitterbucks is an ERC20 token specific for the event. So on March 2nd, you click there, and you have to confirm that you have checked in on the event. When you check in, you receive a code to claim the tokens. So you just put the code there, you sign your transaction, and you're done. You will have some Bitterbucks tokens. In this example, we have 10. Then, now that you have the Bitterbucks tokens, you can go to any of the food trucks, and you can basically buy food. And there is a scan to buy button. So in the food truck, they will have a QR code. You put it there, you scan it, and you just pay for the food. When you use the QR code, it will populate the transaction automatically. And you confirm, send the transaction, you pay, and that's it. You get food for free. And we have a Paymaster behind the scene that is actually detecting that you as a user are paying ERC20 tokens to a food truck, and we are taking care of the transaction fees. So you don't have to have any Ether on your wallet. It's completely gasless for the users. And this is a way to improve user experience, that this is something that we think it will help onboard a lot of people into Web3. Apart from that, zkSync, we are one of the main sponsors. We are sponsoring the hackathon. We have a few bounties as well. We've built the food truck experience. And tomorrow we have our developer day. You have to go, if you search zkSync on Eventbrite, you will find it. If not, I have a QR code at the end. And we have a lot of talks, panels, and workshops. We are all over the place. We are doing a lot of things. So, main takeaways. zkSync Era is a L2 rollup powered by a zk EVM. We are an EVM Plus because, apart from being compatible with the EVM, we also have account abstraction and Paymasters already live on the protocol. Account abstraction is implemented at the protocol level, so it's not something that we build on top. And account abstraction improves the user experience. If you have better user experience, we increase adoption, which is our mission. And Paymasters are pretty cool. Here are a few links if you want to know more about account abstraction. We have 2 pretty cool tutorials on our docs. One about how to create your own Paymaster. Another one on how to create smart contract accounts. There are multi-sig accounts, native multi-sig accounts. In our docs, you will have a lot of more information in general about zkSync Era. In our ecosystem page, you will find all the projects that are deploying on zkSync. We have more than 150 projects, like from big DeFi protocols to NFT marketplaces, games, wallets, everything. And then that's our Discord. If you are developing an application, you have some questions, just go to our Discord. And follow us on Twitter, because we post a lot of updates there as well. And that's basically it. In this QR code, if you scan it, you will find a link to the slide. And in the slides, you will have all the links that I mentioned. And we also have the link to our developer day, which is tomorrow. Also a link to a previous workshop that we did about introduction to layer 2s, repository, and our jobs board, because we're hiring at Matter Labs. So yeah, that's it. Just in time. Thank you everyone for coming.